Welcome to lesson 4.3. In this lesson, our main goal is solving equations. Now, I've talked about in previous lessons that the hardest part of solving these equations is looking at the equation and knowing what to do, what to start with. How do I even begin this problem? That is what I would like to practice today. So we're going to start with this problem right here. Now, what I would like you to do is take a second to pause this video and brainstorm different ideas of how you might be able to start this problem. When you think you have a pretty good idea, come back and then we'll check and see how you did. Okay. Now, for me, when I first see this problem, I would notice pretty quickly that 16 is a power of 2. So, if I change that 16 to 2 to the 4th, then I know I can use my rules of exponents to bring that 2 to the 4th up, make the exponent negative, and now I have my 1-to-1 property. That's always a pretty good hint if you can get two exponentials of the same base. Then you can use 1-to-1, and it's way easier to solve. So here I've got two exponentials, same base, so then I can just set these equal to each other, and then bring everything to one side and factor it. Set them both equal to 0, and I get x equals -4 and x equals -1. Now, you may remember at the end of last lesson, we needed to check our answers. We only need to do that if the problem starts with a logarithm. If there's a logarithm up here in the beginning, then we need to plug our answers back in and make sure they work. Since I don't have any logarithms here, I can just stick with my answers and say we're good to go. Let's look at another one. This one's a little bit harder. So once again, I'm going to give you some time to pause the video, brainstorm some ideas of what you could do to solve this problem, then come back and we'll see how you did. Okay, now this one, I have two exponentials here, so my instinct would be to try to get that 1-to-1 property to work, especially because I noticed pretty quickly that I have a 25 in here, and 25 is 5 squared to the x. And I remember my rules of exponents, that if I have a power raised to another power, I multiply those exponents. So 2 times x gives me 2x, and now I've got this. Now I can see that I'm getting a lot closer to my 1-to-1 property. I've got 5s on both sides. However, I do have that 2 and the 10 that are kind of tricky. Now, a lot of you might be like, hey, let's just multiply this 2 and this 5, change it to a 10. And then I've got 10s. You actually can't do that because, remember, order of operations says I have to deal with this exponent before I can deal with this multiplication. So you can't just multiply those together and get 10. However, I can get rid of the 2 by dividing it. Now, I can't divide the 5 by 2 because same thing, order of operations, you have that exponent, it kind of gets in the way. But I can divide the 10 by 2. So I end up with this. Now I notice that, hey, that 5 has a secret 1 attached to it. So now these have the same base. So I know my rules of exponents. If I'm multiplying, then I can add the exponents. So I can add the exponents together. And now I finally have 1-to-1 property. So now that I have 1-to-1, set them equal to each other, and solve for x. So I get x equals 2. And there we go, that's example 2. So that is all I'm going to do for this video for now. In the next video, we'll look at the next 2 problems, and we'll do the same thing. Have you pause and brainstorm how to start this on your own, because that is the hardest part of these problems, and then we'll work through it together.